arithmetic sequence is a sequence where each term is growing by the same amount, which we often refer to as the common difference in that sequence. So the sequence we looked at before, 3, 5, 7, 9, is called an arithmetic sequence because each term is growing by the same amount, plus 2, plus 2, plus 2, so on. And similarly, if it was dropping by 2, or like say it was going to 3, 1, negative 3, negative 5, that would also be an arithmetic sequence. And if you wanted to know, well, what basically the little diagram I gave over here gives you the definition of an arithmetic sequence along with how do I write its formula. So it says an arithmetic sequence is of the form a plus d, a plus 2d, a plus 3d, where this is just kind of, if I'm trying to read this, a is denoted to be the first term of the arithmetic sequence. And then what it's in is, well, the second term is a plus d. Basically, what have I added to that? So like here, the first term is a would be 3. Sorry, let me get my tablet set up. A is equal to 3. And then d would be, since the next term was 5, it would be, well, I started with 3 and added 2 to it. Or, often I refer to that as that's the common difference. That's what is being added between the terms, where a is the first term. And then notice that the third term is written to be a plus 2d. Well, that's just because if the first term was 3, the second term I added 2 to that. And then after it, to get to 7, that would be plus another 2, a plus d plus d. And a plus d is equivalent to a plus 2d. Then the fourth term of that sequence, 9, would add another 2, right? Because if I'm going plus 2, plus 2, plus 2, I could look at that as, well, how many 2's have I added from the start? Because the first term was 3. To get to 9, I had to add 1, 2, 3 groups of 2, so that would be a plus 3d. And so on. Basically, a plus 4d would be the fifth term, so on and so forth. And this leads us to understanding what we call the general formula for an arithmetic sequence. But basically, any arithmetic sequence will follow the following general formula, where a sub n is always equal to a plus n minus 1d. And this is because the first term is a. And so if I wanted to say figure out what is a sub 1 by evaluating that formula, that would just be a plus 1 minus 1 times d. Because here in the first term, n is always 1. And if I plug in 1 into this formula, since 1 is a 0 of the factor n minus 1, that would of course give us a plus 0d, which is just going to be a. And that's exactly what I want to have happen, right? Because what I said earlier is that a is the first term, and here, if I use this formula, that's exactly what will happen. a1 will give me a. And then we could look at what happens if we plug in a2 into that generic formula. Well, I would get a plus 2 minus 1d. And of course, 2 minus 1 is 1, so this would just give me a plus d. And as I said, that's always what we want in the second term. We want to add a common difference. And as we plug in larger and larger n, this would then give me a3 is equal to a plus 3 minus 1d, which would be a plus 2d. And as I was saying before, that's exactly what we want in an arithmetic sequence. And so, what you can just remember from this is that the generic formula for an arithmetic sequence, if you want to find it, you can always use this formula. So it's a formula for the formula. And in this particular case, let's say I wanted to know its formula. Well, in the last video, we examined that formula and I just gave it to you. But what I said is, well, how do we know how to find it? That's exactly my point, is you can use the general formula to find the formula. So here, if we know a and d, that's all we need to plug in. Well, it would be a plus n minus 1d. And you're always going to leave n in there because, remember, if we're trying to write a formula for the sequence, we want n to be a part of it. N is like the variable. It's kind of like our x. And we want to make sure that we have that still. But a and d are what we know. And that, our formula should still have n in it. And then, we could simplify this by distributive property, but that you could just leave the formula like this. But by distributive property, this would be 2 would distribute to each term, so this would be 2n minus 2. And then if we combine like terms, this would give us 2n minus 1. But we would end up with that same formula from before. And basically, this is how you can find the formula for an arithmetic sequence. So let's look at one more example. The next one says, is the sequence 105, 88, 69, 50 arithmetic? If so, write its formula and find a20. And since it's in the section under arithmetic sequences, we can probably guess that it is. But basically my recommendation is if you're trying to figure out if it's arithmetic or not, see, does it have a common difference? Because if it's not the same amount that's being added or subtracted from each term, it is not arithmetic and you can't use this formula. But this one, notice that and you can always just take the difference of the first two terms to figure this out. So basically I could say, well, what's 107 minus 88? That would be 19. And what I want to see is, well, is that the same difference between the next term? So then I could check, well, what is 88 minus 19? That's 69. And then 69 minus 19 is 50. And here, every term that I was given is minus 19. So yes, it's arithmetic. The common difference would be negative 19. And so yeah, A is always the first term, in this case 107, and D is always that common difference, which when it is being subtracted, you want to make sure that your difference is negative, because it's not like the prior example we were adding to from term to term to term. So D was positive, but when it's being subtracted from term to term, you want to make sure that you plug in a negative for D. And we're ready to go. So basically, now I could write my formula. A sub n is equal to A, 107, plus n minus 1 times D, negative 19. And I could then use the distributive property to clean up the formula a little bit. So this would be 107, negative 19 times n is, or I have n times negative 19, which is negative 19n, and then negative 1 times negative 19 is plus 19. And so this would give me, in this case, negative 19n plus 107, that should be 126, 107 plus 19. And here we would have the general formula for this sequence. And also, if you want to check your answer to make sure, is this A sub n or not, obviously what the whole point of this formula is if I then plug in n for A sub n, here, this should be the equivalent to the sequence. Every term should be consistent. So like what we could do is check out the first term. What is A sub 1? So I would do negative 19 times 1 plus 126. And notice that that gives me 107. That's consistent to my starting term. So that's so far so good. I could then check, well, what about the second term? Negative 19 times 2 plus 126. And of course, since I'm basically, this is just subtracting another 19, this will work exactly right, because what I did is I checked to make sure each one was subtracted by 19. That's exactly what this is going to do. So we're good to go. And that's the general idea of arithmetic sequences. In the next video, I want to talk about geometric sequences, very, very similar, with just one important key difference. And then eventually I want to talk about how do you distinguish between arithmetic, geometric, or neither.